A quantity having only magnitude but not direction is called a scalar quantity. A quantity having both magnitude and direction is called a vector quantity. A unit vector is denoted as A cap. Suppose if A is a vector, then the unit vector along vector A is given by vector A divided by its own length. Vector B is equal to -2 into vector A, that is vector B is equal to lambda into vector A times for a constant lambda. Therefore, A and B are collinear. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today I am going to take the very important and easiest chapter, vector algebra. So now, after matrices and determinants in the previous class, now I took this class for revision because this is a little bit connected to matrices and determinants evaluation. So let us discuss this. This is very simple and a very important chapter for the point of examination. Let me see what is the weightage for this. Now for this academic year 2020-22, for your April 22 examination, so the weightage for this chapter particularly is you will get two 2-mark questions, 1-mark questions. So there are two 1-mark questions and two 2-mark questions and two 3-mark questions. So no 4 marks, 5 marks and 6 marks. Only 1 marker, 2 marker and 3 marker question. So all two marks, 2 marks question, 3 marks question, 1 mark question. 1 mark question, 2 questions you will get, 2 mark questions, 2 marks, 2 questions you will get, and for 3 marks also you will get 2 questions. Totally 6 plus 4 plus 2, that is 12 marks. Okay. So very easily you can get 12 marks from this chapter, right? Now let us come to the definition and the types and how to evaluate the vectors. Now let us come to the definitions. So you are familiar with the definition of the vector and the types of vectors. Okay, let me explain once again the concept of the vectors. Now vector means nothing but a quantity having both magnitude and direction. Magnitude is nothing but the length and the direction is called a vector quantity. So a quantity having both magnitude and direction is called a vector quantity. Example for vectors are velocity, force, acceleration. These are all example for vector quantity. Okay, so a quantity having both magnitude and direction is called a vector quantity. The examples, few examples for vector quantities are velocity, force, acceleration. These are all example for vector quantities. Okay, now the opposite of a vector is a scalar quantity, a quantity having only magnitude but not direction. For example, length, mass, time, they are all example for a scalar quantity. Just it is a number, 10 centimeters, 10 meters, 30 kgs, 30 grams. So just it's a scalar quantity. Therefore, a quantity having only magnitude but not direction is called a scalar quantity. A quantity having both magnitude and direction is called a vector quantity. Now a vector is represented by a direct line segment AB. This is a vector. The vector is represented by a direct line segment and the arrow mark indicates the direction of the vector. So here is from A to B. This is denoted as vector A or vector AB or vector A. The arrow mark indicates the direction of the vector from A to B. So this is vector A or vector AB. So here A is called the initial position and B is called the terminal position. So at this terminal position it may take any direction. It will become the initial point for the other vector. So therefore it is the initial point and this is the terminal point. So a vector is represented by a direct line segment AB and the arrow mark indicates the direction of the vector. This is vector A. This is called the initial point and this is called as the terminal point of a vector. Okay. Now AB, the length of this vector is denoted as length of vector AB. This is called the length or magnitude. Length of AB or vector AB is nothing but length or magnitude of the vector AB. Okay. Now the length is denoted as mod AB. This is modulus of AB or modulus of vector A is nothing but the length. Right. Now let us come to the scalar quantity. A quantity having only magnitude but not direction is called a scalar quantity. And example for scalar quantities are length, mass, time, etc. are all scalar quantities. Now let us come to the position vector. Now what is PV? PV is nothing but the position vector of a point. Now let us consider a point P, X, Y, Z be any point. Let P, X, Y, Z be any point in the space. Then OP is called the position vector of point P with respect to the origin O 0, 0, 0. Hence the position vector of this OP E with respect to origin is denoted as OP is equal to, and it is given by, suppose if I, J, K are the unit vectors, then OP is equal to Xi plus Yj plus Zk along X, Y and Z axis. Now the magnitude of such a vector is denoted as OP and is given by, the magnitude of this is mod of this, and the modulus of this is equal to square root of x square plus y square plus z square. The magnitude is nothing but root of x square plus y square plus z square is the magnitude of the vector AB. So in case of a vector in, if P x comma y is the point, then the position vector with respect to the origin is OP is equal to xi plus yj, and the magnitude of this vector OP is equal to root of x square plus y square. Suppose if I, J, K are the unit vectors, then the magnitude of this is given by OP is equal to mod of xi plus yj plus zk. Therefore, OP is equal to root of x square plus y square plus z square. That's it. Hope you followed. Now, see here, this is the point P, X, Y, Z with respect to the origin along x axis, y axis and z axis. So therefore, R, the position vector of this point P, X, Y, Z is OP. Vector R is equal to, here vector R can be written as xi plus yj plus zk. R is equal to x into I plus y into j plus z into k. Okay. Now see here, the position vector of the point A, B, C, A, B and C with respect to the origin is denoted as vector A, vector B and vector C. Vector A, vector B and vector C are the position vectors of the point with respect to the origin. Therefore, vector OA is equal to vector A, vector OB is equal to vector B and vector OC is equal to vector A, B, C. So, vector OA is equal to vector A and vector OB is equal to vector B and vector OC is equal to vector C. The position vector of these points are OA, OB and OC with respect to the origin. Now, let us come to the types of vector. Now, let us discuss regarding the types of vectors. So, these are very important. Definitely, you will get one definition, one type of vector. So in the examination, they may ask, define a zero vector or a unit vector. So like that for 1 mark. So 1 mark, you may expect one question from types of vectors. Okay. Now let us discuss regarding the types of vectors. So 1 mark question, zero vector, null vector. A vector whose initial and terminal point coincides is called a zero vector or a null vector, denoted as 0. For a zero vector or a null vector, the initial point and the terminal point are same. So if the initial point and the terminal point of a vector coincides, then it is called a null vector or a zero vector. So a vector whose initial and terminal point coincides is called a zero vector or it is called as a null vector, denoted as 0. So for a null vector, A into A, length of A or length of B and B remains the same, A and A, 0. That is A into A vector, B into B vector. So, or we can also define a vector whose magnitude is 0. A vector whose magnitude is 0 is called a null vector or a zero vector, denoted as O. This is zero vector, a null vector. So, a vector whose initial and terminal points coincide each other is called a null vector, or a vector whose magnitude is 0 is also called as a null vector or a zero vector. Now, unit vector. Let us come to an unit vector. Unit vector. Unit means 1. As already you know, unit means 1. That means a vector having the unit magnitude. A vector whose magnitude is unity, that is 1 unit, is called a unit vector and it is denoted as a cap. So, a vector whose magnitude is 1 unity is called a unit vector. For example, let us consider a vector. Vector A is equal to cos x into I plus sin x into j cap. Then the magnitude of this vector is vector A is equal to mod of cos xi plus sin of x into j cap. So this is nothing but, as I told, to find the magnitude of a vector, we are going to use the coefficient of vector I whole square plus coefficient of j vector whole square plus coefficient of the k cap whole square. So that is nothing but here cos square x plus sin square x. So cos square plus sin square is 1, this is equal to 1. So the magnitude of this vector is 1, so this is a unit vector. A vector whose magnitude is 1 is called a unit vector. Okay. So a unit vector is denoted as A cap. Suppose if A is a vector, then the unit vector along vector A is given by vector A divided by its own length. So unit vector of A is equal to vector A divided by own length. The length of the vector will give the unit vector. Okay. Now let us come to the next co-initial vector. Co-initial vectors. Two or more vectors having the same initial point are called co-initial vector. So here vector OA, vector OB and vector OC have the same initial point O. Therefore, this is called co-initial vectors. These are called co-initial vectors. So two or more vectors having the same initial point, are called co-initial vectors. So here vector OA, then vector OB and vector OC, these three will have the same initial point O, therefore they are called as a co-initial vector. Suppose if there are two vectors, say for example vector OA and vector OB, then also we can say vector OA and OB are co-initial, because the initial point of these two vectors is vector O. Okay. So vectors, two or more vectors having the same initial point are called co-initial vectors. That's it. Now let us come to the next important type of vector is collinear vectors. Collinear. Two or more vectors are said to be collinear if they are parallel to the same line. So two or more vectors are said to be collinear if they are parallel to the same line. Let us consider, for example, vector A. This is vector. Suppose this is vector AB and vector BC are in the same line. They are parallel to the same line. We can say that vector AB and BC are collinear vectors. Okay. Suppose if there are two vectors, say for example, if there are two vectors, if A and B are any two vectors, then these vectors are said to be collinear if and only if vector A is equal to lambda into vector B, where lambda is a constant. For some constant lambda, vector A is equal to lambda into vector B. If this condition is satisfied, you can say that the vectors are collinear. So while solving the problems, if you solve this condition, vector A is equal to lambda into vector B, then you can say that A and B are collinear vectors, right? Now let us come to the next type, equal vectors. Two vectors are said to be equal, vector A and B are said to be equal if and only if they have same magnitude and direction. Two vectors are said to be equal if and only if they are in same direction and having the same equal magnitude. Suppose two vectors A and B are said to be equal if and only if length of A is equal to length of B and the direction is also same. Let us consider this is vector AB, another vector CD. These two vectors, this is vector A, let us call it as vector A, and this is vector B. So two vectors, vector AB and vector BC are said to be equal. Let us call CB is equal to vector B, AB is equal to vector A, and vector A length is equal to vector B, that is length of vector AB is equal to length of vector CD, then the vector A is equal to vector B. Okay. So here two vectors are said to be equal if and only if they have same magnitude and direction. Two vectors having the same magnitude and in same direction, then the vectors are said to be equal vectors. Okay. So now the next important you may expect for the examination is negative of a vector. Very important definition. A vector whose magnitude is same as that of the given vector but direction is opposite to that of the vector. So a vector whose magnitude is same as that of the given vector, but the direction is opposite to that of the given vector is called the negative of a vector. Now let us consider, for example, the negative vector of vector AB is BA, that is vector BA is equal to minus AB. Minus AB. See here, vector A to B, this is vector AB. The negative of this vector is vector BA, that is from B to A, BA. Now the direction is opposite to that of the given vector, this is from A to B and this is from B to A. So therefore we can write vector BA is also equal to minus of vector AB. Minus of vector A. Vector B to A is equal to minus of AB. Okay. So BA is equal to minus of AB is called the negative of a vector. So a vector whose magnitude is same as that of the given vector, but the direction is opposite to that of the given vector is called a negative of a vector, denoted as A. Suppose if A is a vector, then the negative of this A is denoted as minus A. Whereas the magnitude of A and minus A will remain the same. That's it. Okay. So that is regarding the negative vector is concerned. Now, these are few types of vectors. Okay. Hope you followed. Now, let us discuss few problems based on the unit vectors. Now, let us come to the unit vector. Now, unit vector along vector A. Unit vector along vector A. The unit vector along a vector A is denoted as A cap. This is vector. So let us consider a vector A. This is vector A from A to B, and this is called the unit vector. The unit vector is, this is the unit vector and A cap. Therefore, the unit vector A cap is given by vector A divided by its own length. Vector A divided by length of vector A will gives the unit vector. So where this magnitude is nothing but the length of vector A. Okay. Suppose the unit vector along the vector A. Suppose if A is a vector along AB, then the unit vector along AB is denoted as A cap, and this A cap is given by vector A divided by its own length. Now let us consider, for example, if vector A is equal to I plus J plus 2k, then the unit vector, how to find the unit vector? The unit vector, before that let us find out the magnitude. The magnitude of this is magnitude of I plus J plus 2k. This is equal to square root of 1 square is 1 plus 1 square is 1 plus 2 square is 4. This is root 6. So therefore the unit vector, so unit vector along vector A is equal to A cap, that is vector A divided by its own length. What is vector A? I plus J plus 2k. Vector I plus J plus 2k divided by root 6. If you want, you can put it in the form. A cap is equal to 1 over root 6 into I plus J plus 2 times the vector k. This, okay. So this is how we are going to find the unit vector. So you may expect this for 1 mark, that is unit vector problem like this. Okay, a definition or a problem to find the unit vector along the given direction. I will take this type of problems while solving the problem. For the time being, just have given an example how to find the unit vector. Okay. Now let us come to the next components of the vector. Here the components of the vectors are, now let us consider here, this is the unit vector along x-axis, unit vector along y-axis and unit vector along z-axis. So I is a unit vector along x-axis, therefore the coordinates of the point A is 1, 0, 0, and this j is a unit vector along the y-axis, therefore the coordinates of the point B are 0, 1, 0, and k is a unit vector along the z-axis, therefore the coordinates of the point C 0, 0, 1. So in the x-axis 1, 0, 0, y-axis 0, 1, 0, and in the z-axis we will have 0, 0, 1. So therefore here if length of OA, length of OB and length of OC is equal to 1, they are all unit vectors. Length of OA is 1, length of OB is equal to 1, length of OC is also equal to 1. Having one as a unit vector of magnitude 1 along OX, OY and OZ directions. I cap, J cap and Z cap are the unit vectors of the point P, X, Y and Z. So therefore, the position vector of the point P is denoted as vector OP is equal to xi plus xi cap plus yj cap plus zk cap. Okay. Now, so the position vector of the point, any point P, X, Y, Z is vector OP is equal to x into vector I cap plus y into vector j cap plus z into vector k cap. Now, let us consider this. The position vector of the point P, x comma y is given by vector OP is equal to x into vector I plus y into vector j, and the magnitude or length of this vector OP, this is very important. So, very important, magnitude of vector OP is equal to mod of xi plus yj cap. That is nothing but the coefficient of I and the coefficient of j. What is the coefficient of I cap is x, coefficient of y cap is j. So, x square plus y square. So, the magnitude of this is given by length of x square plus y square. Similarly, the position vector of a point x, y, z. Suppose if the position vector for this OP is nothing but, so, xi plus yj. Suppose if for a point P, x comma y comma z, then the position vector OP is equal to xi plus yj plus zk. So, that is the position vector OP is equal to x into I plus y into j plus z into k. This is. Now, the magnitude or length of OP is given by the magnitude of this. So, the magnitude of this is nothing but root of x, coefficient of I is x square, coefficient of j whole square is y square plus k coefficient is k whole square. Root of x square plus y square plus z square will give the magnitude. This is also very important form. Right. So, if A and B are any two vectors, then vector A is equal to A1i plus A2j plus A3k and vector B is equal to B1i plus B2j plus B3k. Then we can find the sum of the vectors as A plus B and the difference of the vectors as A minus B. Okay. So, you can find the sum or difference of the two vectors for vector A and B. A plus B is the addition of vectors, A minus B is the subtraction of vectors, sum or difference of the vectors. Now, let me take the general concept how we are going to find the sum or difference of the two vectors. Let me consider, let vector A is equal to A1i plus A2j plus A3k, then vector B is equal to B1i B2j plus B3k. Now, sum of vectors, addition of vectors, sum, addition. A plus B is equal to, just add the coefficients of I, J and K separately. That's how coefficient of I is A1, I is B1, A1 plus B1 into I, coefficient of J are A2 plus B2 into J, A3 plus B3 into K. So, the addition of vectors can be done by well-known law that is called as law of parallelogram of forces or law of triangular forces. Suppose if two forces are vectors acting along the, if two vectors are acting along the adjacent sides of a parallelogram taken in order like this, then the diagonal passing through them will give the resultant. So, this is vector R. Vector R is equal to vector A plus vector B. Right. So, that you know how to find, how to add. So, here just add the coefficient of I, coefficient of J and coefficient of K separately for the vectors, given vector. Similarly, the difference, subtraction, the difference of these two. Suppose if we want to subtract these two vectors, A minus B is equal to same, A1 minus B1i plus A2 minus B2j plus A3 minus B3k. Separately subtract the coefficients of I, coefficients of J and coefficient of. So, this is how we are going to add and sum or difference of the two vectors. Now, so there are some properties. What are the properties? K into vector A plus B. If you multiply the sum by any constant K, you can multiply the whole sum by K, or you can multiply individually vector K into vector A plus K into vector B. where k is a constant. This k is a constant. So k into vector a plus b is equal to k into vector a plus k into vector b, where k is any constant. Now suppose if k is any constant, k into m into vector a, m is also a constant, k into vector m into vector a can also be written as km into vector a. You can multiply these two constants separately, km into vector a. Now if a and b are any two vectors, then as told in the previous definition itself, the vectors are said to be collinear if and only if vector b is equal to lambda times vector a, where lambda is a constant. To verify the vectors, suppose if the problem is given, you can do in any method. So if a and b are any two vectors, to verify the given problem as collinear, you can write vector b is equal to lambda into vector a, or very easiest method is find out the ratios. If the ratios are proportional, a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda, then also you can say that they are collinear vectors. Okay. Now let us come to the problem. Straight away I will take the problems. So components of vectors and their position vectors. In this you may expect 1 2 marks question or 1 mark 1 question. Right. Now let us discuss. Find the value of x, y and z so that the vectors a xi plus 2j plus zk and the vector b is equal to 2i plus yj plus k are equal. So usually you will get this type of question for 1 mark. What is given here? Given that two vectors are equal, vector a is equal to vector b. So two vectors are said to be equal if and only if they are in same direction and the magnitude also same. Here instead of magnitude, the corresponding coefficients of I, j and k must be equal. That's it. Now let us write what is given. Given that vector a is equal to vector b, that is, what is vector a? X into I plus 2 into j cap plus z into k cap is equal to vector b 2 into I cap plus y into j cap plus k cap. That's it. Now equate the coefficients here. The coefficient of I is x. Here the coefficient of I is 2. So therefore x is equal to 2. What is the coefficient of j? 2. Here the coefficient of j is y. So y is equal to 2. And the coefficient of k is z. Here the coefficient of k is 1. So therefore x is equal to 2, y is equal to 2 and z is equal to. So these are the values of x, y and z. So if you do this much, you will get 1 mark or 2 mark. 1 mark or question usually. That's it. So x is equal to 2 and y is equal to 2 and z is equal to 1. That's it. Now let us come to the next problem. Now find the unit vector in the direction of vector A. So these are all very important for your 2022 examination. Definitely you will get one question from this. Find the unit vector. The unit vector along vector A is given by A cap is equal to vector A divided by its own length. Now unit vector, I will write the solution. Unit vector along vector A is equal to A cap. A cap is equal to vector A divided by its own length. What is vector A? 2i cap plus 3j cap plus k cap divided by length, square root of 2 square 4 plus 3 square 9 plus 1 square is 1. So that is equal to 2 into I plus 3 into j plus k cap divided by 9 plus 1, 10 plus 1 is 14. So therefore the unit vector A cap is equal to 1 by root 14 into 2 times I cap plus 3j cap plus k cap. That's all. If you do this much, you will get 1 mark. Very simple. Now take a similar problem. Find the unit vector in the direction of vector A is equal to I plus j plus k. What is the formula? A cap is equal to vector A divided by its own length. What is A? A is nothing but vector I plus j plus k divided by its own length. Length of this 1 square is 1 plus 1 square is 1 plus 1. Coefficient of I is 1. J is 1. Coefficient of k cap is also 1. So this is equal to I plus j plus k divided by root of 1 plus 1 is 3. So this can also be written as 1 by root 3 into I plus j plus k cap. That's it. If you do this much, you will get 1 mark. Hope you followed. Okay. Now let us come to the next problem. Find a vector in the direction of vector A is equal to I minus 2j that has a magnitude of 7 units. So we have to find a unit vector. Find the unit vector in the direction of vector A whose magnitude is 8 units, there 7 units. There are two questions. So what is the formula for unit vector? Let me write the formula first. A unit vector is vector A cap is equal to vector A divided by its own length. Now what is required to find? To find a vector A. To find this vector A, therefore vector A is given by length of A into A cap. That's it. This is the formula we are going to use. Very simple. So here what is given? A magnitude of the vector is 7 and A cap. Find a vector in the direction of this. Okay. Now therefore the required vector A is equal to 7 times A cap. This is equal to 7 into what is A cap? A cap is nothing but vector A divided by its own length. What is vector A? I minus 2j divided by the length of this vector. So 1 plus 2 square. 2 square is 4. So this can be written as 7 into vector I minus 2j divided by root 5. So therefore the required answer is 7 by root 5 times the vector I minus 2j. So this is the vector whose magnitude is 7. Okay, that's it. Now suppose if you want, you can verify. If you write the magnitude for this vector, 7 by root 5 remains the same. The magnitude of this is 1 plus root of 1 plus 4 is root 5. Root 5 gets cancelled. You will get 7. That's it. Very simple. So therefore the required answer is 7 by root 5 into I minus 2j. Similarly, let us take this is 2 marker question or 1 marker question. Now find the unit vector in the direction of vector A. Find the unit vector in the direction of vector A is equal to 5i minus j plus 2k whose magnitude is 8 units. Same type problem. What is given? Length of A is equal to 8. Now what is the formula? The vector A is equal to 8 times the unit vector. So this is equal to 8 into unit vector. Formula is vector A divided by its own length. Vector A is nothing but 5i minus j plus 2k cap divided by length of this. What is the length? Length of this is 5 square is 25 plus 1 square is 1 plus 2 square is 4. So that is nothing but 25 plus 5 is 30. 8 by root 30 into vector 5i minus j plus 2k. This is the vector. So if it is possible to simplify, you can simplify it. So therefore this can also be written as, so if you want, you can simplify. 8 5s are 40 by root 30 into I minus 8 by root 30 into j plus 8 2s are 16 by root 30 into k cap. So these are the required vectors. That's it. Okay. This is how we are going to find the unit vector for the given problem, depending on, just very simple. Whatever the magnitude is given, multiply. That's it. So A is equal to 7 times A cap. Here A is equal to 8 times A cap. That's all. You will get the answer. Hope you followed this. Okay. Now let us come to the next concept. Find the unit vector in the direction of sum of the vectors. Now here sum of the vectors. So we will have an addition of vectors as well as the unit vector. So this is very important. Find the unit vector in the direction of the sum of the vectors. Usually you may expect this for 2 marker question. Now find out vector A plus B. What is A plus B? Sum of the vectors is nothing but A plus B. So A plus B, vector 2i plus 2j minus 5k plus 2i plus j plus 3k. Add this. So as I told, the addition of vectors, just add the coefficients of I, j and k. What is the coefficient of I? 2. Coefficient of I is 2. 2 plus 2 is 4i. Here 2i plus j. Coefficients 2 plus 1 is 3j. And the coefficient of k is minus 5. And here it is plus 3. Minus 5 plus 3 is minus 2k cap. Okay. Then just find out the magnitude. Magnitude of A plus B is equal to root of 4 4s are 16, 3 3s are 9, 2 2s are 4. So this is equal to 16 plus 4, 20 plus 9 is equal to 29. So first find out a plus b, sum a plus b is equal to 2i plus 2j minus 5k plus 2i plus j plus 3k. 2 plus 2 is 4i, 2 plus 1 is 3j, minus 5 plus 3k is minus 2k. The magnitude of this is 4 4s are 16 plus 9 plus 4 is root 29. Now what is required to find the unit vector? Therefore, the unit vector in the direction of sum of a plus b means unit vector along a plus b is equal to, unit vector is nothing but vector divided by its own length. So what is vector a plus b? A plus b is equal to 4i plus 3j minus 2k divided by its length. What is the length? Root of 29. So therefore you can stop here itself, or if you want further step, 4 divided by root 29 times I plus 3 divided by root 29 times j minus 2 divided by root of 29 times vector k cap. This is the unit vector. So maybe this is for 2 marks. So if you do this much, definitely you will get 2 marks. Okay. Just find out a plus b and the length of a plus b. As usual, you know the unit vector is vector divided by its own length. If there are 3 vectors, suppose if there are 3 vectors a, b and c, find the unit vector along the sum of the vectors a plus b plus c means vector a plus b plus c divided by length of a plus b plus c will give the unit vector. Okay, that's it. Hope you are following, right? Now, let us come to the next concept, that is vector joining the 2 points. So, now let us consider if a x1, y1, z1, b x2, y2, z2 be any 2 points, then the vector joining these 2 points a x1, y1, z1 and b x2, y2, z2 is vector ab is equal to, here vector ab can be written as vector ob minus vector oa. Vector ob minus vector oa will give the vector ab. So vector ab can be written as ob minus oa vector. So as usual, suppose if ab is the vector, then very simple, just find out second vector minus first vector, the position vector of the second vector minus the first vector, that is from a to b. ob minus oa vector, vector ob minus vector os. So therefore ob minus oa can be written as x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Just subtract these values. That's it. So here x2 minus x1i plus y2 minus y1j plus z1 minus z2 minus z1k will give the vector ab. Okay. So this is how we are going to find out the position vector of the point ab. Now let us consider a small example. If a is equal to 1, 3, 5 and b is equal to 2, minus 3, 1, find the magnitude of vector ab. First find out position vector of ab. Now position vector of ab is equal to vector ob minus oa vector. Okay. Now vector ob minus oa vector is nothing but use this formula x2 minus x1. So this is x1 y1 z1. This is x2 y2 z2. 2 minus 1 into I plus minus 3 minus 3 minus 3 minus 3 into j plus z2 minus z1 1 minus 5k. So this is equal to I minus 3 is minus 6j minus 4k. This is the position vector of AB, second vector minus first vector. And the magnitude of this is given by the length of AB is equal to root of. So 1 square is 1, minus 6 square is plus 36, again minus 4 square is plus 16. So this is 1 square is 1 plus minus 6 square, I will write here. So don't get confused, because negative square is a positive, the negative square is positive. You won't get negative magnitude, only positive. 1 square is 1 plus 6 square is 36 plus 4 square is 16. So this is equal to root of 36 plus 16 plus 1. Simplify this, that's it. So this 1 plus 36 plus 16, 6 plus 6, 12, 12, 2, 1, 3, 4 plus 1, 5. So 52. That's it. So 52 units is the magnitude of this vector AB. That's it. The position vector of AB is OB minus OA and the magnitude is root 52. Now let us come to the next. What is given? Show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear vectors. So this can be done in two methods. I'll show the both methods. The first method. Now what is vector A? A is equal to 2i minus 3j plus 4k and vector B is equal to minus 4i plus 6j minus 8k. Now let us consider now from vector B. What is vector B? Minus 4i plus 6j minus 8k. If you observe carefully, you can take the common factor. What is the common factor? Minus 2. So if you take minus 2i, minus into plus minus 3j, minus into minus plus 4k. What is this equal to? Minus 2 into, if you observe carefully, 2i minus 3j plus 4k is nothing but your given vector A. Given vector. So here this is nothing but vector B is equal to minus 2 into vector A, that is vector B is equal to lambda into vector A times for a constant lambda. Therefore, A and B are collinear. You can say that these are collinear vectors. Or other method, you can also solve like this. So as I told, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Here, what are the ratios? The coefficient of I are 2 by minus 4 is equal to minus 3 by 6 is equal to 4 divided by minus 8. So this is minus 1 by 2, minus 1 by 2. So therefore, A and B are collinear. That's it. This is also the method to solve. Okay. Any method you can use to solve this for collinearity. Okay. So this is how we are going to solve the problem. So these are few problems based on the addition, subtraction, unit vectors and the position vectors. So that's all regarding today's session. Let us meet with a different concept in the next class. Thank you. Thank you very much.